Hey, welcome back to Mr. PL's with Precal. This is Unit 3, Topic 1, Lesson number 6. We're still getting into our 6 trig functions, and we're going to be talking about, it says, students be able to relate trig ratios to trigs and unit circle. Give secant of theta is 10 over 8. So keep in mind that secant is the reciprocal of cosine, and if cosine is x over r, which is the same thing as the cosine is adjacent over hypotenuse, then secant would be hypotenuse over adjacent. So if I make my triangle and I say this is theta, so this would be this over this. So now I can find the third leg, which I can just use Pythagorean's triplets. This is a 3, 4, 5 triangle, so this is going to be 6. So 3 times 2 is 6, 4 times 2 is 8, and 5 times 2 is 10. So now that I know all 3 sides, now I can find all the trig functions. Cosine, okay, so I did put it in the wrong spot. So let me, because that probably bugs some of you, let me put the theta over here. Because like I said, it's adjacent over hypotenuse. So that would be this one. All right, so sine would be 6 over 10, opposite over hypotenuse, and cosine is obviously 8 over 10, as I've already talked about, and tangent would be y over x, or I'm sorry, tangent would be opposite over adjacent, which would be 6 over 8. And then to find the opposites, so secant was already given, so secant is 10 over 8. Secant of theta, so that would be cosecant, would be the reciprocal of sine, which would be 10 over 6. And then cotangent, I don't know why I'm sleeping on, it's not cotangent, it's, can't remember which letters it used. So that'd be 8 over 6. All right, so how would you find the measure of the angle? So now, I now know that secant is 10 over 8, so that would mean that cosine would be 8 over 10. So cosine of theta equals 8 over 10. Now, the way I'm going to do this is I want to get rid of the word cosine. So I'm going to do the inverse of that, which would be inverse cosine. But if I do inverse cosine to the left-hand side, I have to do inverse cosine of the right-hand side. And then these will basically cancel out. So inverse cosine of cosine basically cancels out, leaving you with just theta. And theta, remember, represents the actual angle itself. So that's what I'm going to put in my calculator. I'm going to put inverse cosine of 8 over 10. If you've never done inverse cosine, it's basically, it's on the cosine button. You just got to press second. So second cosine and then 8 divided by 10. And then it's going to give you an answer of about 36.8 degrees. Now, that's an estimation because I had to round it. Also, if you didn't get the exact same answer as me, so make sure, and there's my calculator right there so you can see what it says. Make sure that you're in degrees by pressing mode, and if you go down, make sure that you're in degrees and not radians, because that will mess things up. Okay, so what are the signs for each of the quadrants? So you know this is positive, positive, this is negative, positive, this is negative, negative, and this is positive, negative. And what quadrants are the trig values positive? So this is, all of them are positive, only sine is positive, only tangent is positive, only cosine is positive. What quadrants trig value is positive? So sine is positive in 1 and 2, cosine is in 1 and 4, and tangent is in 1 and 3. All right, so what if we're given this information? Find sine of theta and tangent of theta if cosine of theta is 8 over 17. Now, keep in mind, it doesn't even matter what the numbers are. I know it's a positive. The fact that it's a positive, if cosine of the angle equals a positive answer, then I know that I'm either dealing with something in quadrant 1 or 4, because those are the only 2 quadrants where cosine can be positive. And it says sine of the angle is also less than 0, which means it's negative. So the only 2 places where sine could be negative, it can't be in 1 or 2, it has to be in either 3 or 4. So that bases on just the process of elimination, so we know that it can only be 4. So we know that the answer is going to be in quadrant 4. All right, so now that we know it's in quadrant 4, so now we can say, well, cosine of theta is 8 over 17, so I build my triangle in that spot. So Cosine, remember, is adjacent over hypotenuse, so I know, so that's got to be 17, and this has got to be 8. So I just need to find out, well, what's this length right here? Actually, let me go this way. All right, so we need to find out what's this. So that's 8 squared plus b squared equals 17 squared. That's 64 plus b squared equals, and I should know this, 17 times 17 is 289. And if I subtract 64 from that, I get 225. And if I do square root of 225, that's a standard one. That's going to be 15 exactly. So 8, 15, 17. I guess I should have known that's one of the kind of standard Pythagorean triplets. All right, so now that I've got all three sides, then I can find, well, what's sine of theta? Sine of theta would be, keep in mind this is down, negative 15 down, so this is positive 8. This hypotenuse is always positive. So sine of theta would be opposites, which would be negative 15 over hypotenuse. And then tangent, and that makes sense because sine cannot be positive in this quadrant. And then tangent would be negative 15 over 8. And once again, tangent also cannot be positive in this quadrant as well. Now, how do I find theta? Well, honestly, I can use any one of the ratios that I want. I'm going to use the cosine one since it's already positive. And I'm going to do inverse cosine of that. But if I have to do that, I have to do inverse cosine of this. Now, why is that important? Because inverse cosine and cosine are inverses of each other, obviously. A lot of people like to call these arc cosine. Arc cosine and cosine are inverses of each other. But then I have to do the same. I have to do arc cosine of 8/17. So arc cosine of 8 divided by 17 is about 61.9 degrees is what my calculator is saying, give or take, roughly. All right, one more of these examples of with solving. So using what we have learned so far, so find cosine of theta and cotangent of theta. If sine of theta is, oh, I guess I didn't probably answer the question. Find sine, oh yeah, I did, there they are. So find cosine and cotangent, COT, sorry, I put CTN earlier, of theta, if sine of theta is negative 4 over 5. Okay, so if we have a circle, so first of all, negative 4 over 5. So sine can only be negative in either 3 or 4. And tangent of theta is greater than 0. So tangent is only greater than 0 in 1 or 3, which tells me that we have to be in quadrant 3. Now that I know we're in quadrant 3, so I can build a triangle that looks like this. Sine, keep in mind, is opposite over hypotenuse, so this is opposite, so this is over here. And then we're trying to find this x value. So that would be negative 4 squared plus b squared equals 5 squared. Keep in mind, this is just a 3, 4, 5 triangle, so I know this is negative 3. I'm not going to go any further with the Pythagorean theorem. All right, so we know we're in quadrant 3. So we know it's negative because it's going left 3, and it's going down 4. And it's hitting at this point right here. Okay, so how do I find these? Cosine of theta, so here's our theta, would be negative 3 over 5. And then cotangent, now tangent would be negative 4 over negative 3, but if you flip that, you got negative 3 over negative 4, or just 3 over 4, same thing, because negative divided by a negative is a positive, and voila, and I'm done. Now, if I wanted to find what is theta, then I would use any one of these, preferably one with, so tangent, for instance, we know is going to be 4 over 3, so tangent of theta, I'm going to stick with one that's positive. All right, so I'm going to do inverse tangent of 4 divided by 3 and parenthesis, and that gives me about 53.1 degrees, give or take, roughly. All right, thanks again for watching, and the last video for this section is going to be just a review video of basically everything that we've done so far. Thanks again for watching. Have a great day.